As we continue on topic 5.8, applications, word problems, we're at number 11 in those workbooks. And what it says is a triangular sign is 2 feet taller than its width and has an area of 24 square feet. What are the dimensions of the sign? So here, again, we're looking for strategy. We have a triangular figure, which I've drawn here. And I've also listed the formula for solving the area of a triangle. Area is 1/2 the base times the height. So what do we know? Well, we don't know the base, which is the width. But we do know that the height is 2 feet more than the base. So we can take the h and substitute for it the base plus 2. So now we only have one variable. So this basically is our formula, and now we are going to substitute. So our area is 24 times 1/2, and we know our base is b, and our height that we replaced with a function of b, so to speak, is b plus 2. So far, again, if you know this, made the picture, put this into algebra, there's where we are. Now we're back to an earlier chapter where we are getting rid of a fraction. So how do we get rid of that 2? Well, we just multiply both sides by 2. So here the 2's cancel out, and now we have 48 equals b squared plus 2b. That's a quadratic equation. How do we solve it? By putting it in standard form. This is now 0. And the method to solve is to factor it. So we want factors of 48 that have a difference of 2. Well, 8 times 6. And we're looking for a positive, larger number, so the plus goes there, and this is minus. And when we solve it, we get b equals 6 here. b equals a -8. Well, you can't have a negative number as a dimension of something, so we reject that one. Our base is 6, and our height is 8. And half of 48 is 24, and there is a solution to this one. As we look at example 12, they talk about a rectangular yard. So as soon as I hear the word rectangular, I make a rectangle. They also tell us that the length of the yard is 20 feet longer than the width. So there's our width, and there's our length, 20 feet longer than the width. And they also tell us that they have a diagonal that is 100 feet long. So that's basically what example 12 is. And they want you to find the dimensions. What's the width? What's the length? Now I could have put it all up here, but let's think about it for a moment. Well, we understand the problem. We've made a diagram. What are we going to use to solve it? Well, anytime you have a right triangle, you're going to use the Pythagorean Theorem. And you know what C is. This is the hypotenuse. The hypotenuse is going to be 100 that we're going to square. We're going to square this side. And we're going to square this side. So this becomes w squared. We're going to use that special technique for squaring this, which is square the first term, multiply these two together, and then double it. So 20w becomes 40w as we square it. And then we square 20, and that's going to give us 400. And that's going to equal, let's see, I need 4 zeros. So that's our basic equation. We're going to group like terms, so we get 2w squared plus 40w. Now we're going to bring the 10,000 over and subtract 400 from it, and that'll give us a negative 9,000, I believe that. And then to make it smaller, we want to divide everything by 2. So this will give us a w squared plus 20w minus half of that is, did I write it down somewhere? Yes, 4,800. And all of that equals 0. And now we have to factor it. Now we're looking at factors of this that have a difference of 20. And we can still use that old technique, but I happen to have worked it out. 60 times 80. And now you have to figure out the signs. We want our larger number to be a positive, so our outers here, this will be the positive, this will be the negative. Notice we then have w equals 60, w equals a negative 80. You can't have a length that's negative 80, so we reject that answer. And here's what our w is. So this is 60, and this is 80. Now, by the way, I don't know if you see it here, you have a 6, 8, 10 right triangle. That's a sister of a 3, 4, 5 right triangle. This is 6, 8, 10. These are sisters. Or in this case, it's 60, 80, 100. Okay, so it checks out nicely, and we're using the Pythagorean Theorem. Now, we did examples of 13 and 14 already. They would be sister or cousin problems. So we'll pass them up. And again, if you want to work on something and you need help, the tutors are available and they can help you with that. I did work them out already. But I thought we'd do number 15, which is sort of new. And you run into this type of problem every once in a while. Now these are in function notation, where we have the cost of something is defined by this function. And the revenue of something is defined by this function. And we use C for cost and R for revenue. And cost is the actual money it takes to produce something. And revenue is the money you get in as you sell these products. And they're looking for a break-even point. So if you had a graph of this, you'd say, well, there's your cost, or I should say there's your revenue, and there's your cost, and they're going to meet at some point. So if you sell more items, then you are in the profit area. But this point right here is your break-even point, where you've made enough money to pay for the cost and the production of this thing. You've taken in that money. And what we're looking for here is some point on the y-scale. So again, let's develop a strategy for doing this. And this works for all of these, by the way. Remember, we said we could replace the function notation with the letter y. So in a sense, we have y equals this, and y equals that. That's our two different equations. We're wondering, where do they intersect? And we have here, can you see that we're having, in a sense, y equals y? And that's the strategy we're going to use. We're going to say 2x squared minus x equals x squared plus x plus 8. So we're saying this y equals this y. That's what we're saying. Y equals y. So this equals that. But it's a quadratic equation. How do we solve it? Think about it for a moment. By putting it in standard form. So we're going to subtract 1x squared. That leaves us with an x squared. We're going to subtract an x. That leaves us with a negative 2x. Because on this side it becomes another negative x. And this becomes a negative 8. And this equals 0 now. We have standard form of the quadratic equation. How do we solve it? Well, the only way we know is by factoring. And we want our larger number to be negative. And if we FOIL it, this makes sense. So here we have x equals negative 2. Here we have x equals 4. Well, our break-even point, no such thing as a negative 2 in this case. So the answer is 4. So what would our break-even point be for this particular example, where the cost is this, the revenue is this. We're looking for a point where they intersect, and we want that y value. Well, our x, this would be the number of units we'd have to sell, is 4. And these were lamps, by the way, and we'd have to sell 4 lamps to break even. Okay. Okay, in example 16, we have a flare that we're going to shoot up. These are always fun. And it's going to reach the height of 160 feet. And we're wondering, how long does it take for the flare to get back to ground level, which is 0? Now it's released with the initial velocity of 48 feet per second. And again, fortunately, we don't have to figure out the formula for this. They're giving it to us here as a function. That the h of t, t is for the time, is equal to a negative 16t squared plus 48t plus 160. But again, what do we do? Well, we're looking for the time that it hits the ground. So here we're saying that this is going to equal 0. So we put a 0 there, and then negative 16t squared plus 48t plus 160. Now we have a quadratic equation. How do we go about solving it? Well, I'm going to make it smaller because I see everything is divisible by a 16. And to keep my first term positive, I'm going to divide everything by a negative 16. So this then just becomes t squared minus 3t minus 10. A lot easier to do. Now, just factor it. So we get t equals negative 2 or t equals 5. Well, it's going to take some time, so we're going to reject the negative, and our t is 5. So the answer to number 16 is 5 seconds. And there's how we did it. Now this is a little wordy, so I'm not going to write it all out, but I'll read it to you. It says, the number of barrels of U.S. ethanol fuel production in millions T years after 1997 is approximated by this function right here. How many years after 1997 were 45 million barrels of ethanol fuel produced? Wow. So again, you read the problem. We've picked out its t years, t is for time, after 1997. So in a sense, this would sort of be our 0. And if we put a 0 in there, we'd end up with something. But what number are we looking for over here? And again, you may have to look at your booklet, but it's 45 years. So what we do is we're going to subtract 45 from both sides to put this in standard form. And you might say, oh, that looks very familiar. It should. That was the previous one we did. So of these two answers, which ones are you going to pick out? Does t equal -2? So for number 17, it would be 5 years after that. And that would be, they didn't ask you, is this going to be 5 years? And the year would be 2003, if they, or how about 2002? If they asked you for that, but they didn't. They only asked how many years after. But if you, depending on this, well, what year was it? 5 years after this was 2002. Okay, we're not going to do number 18. That's a little bit too tedious, and I don't think your teachers are going to assign that. So there we go. This winds up our chapter 5.8.